Alright, so welcome back to another video here looking at Node.js and specifically at Apollo. So what is Apollo? Uh, So after I saw what GraphQL is, which is a new way of building frontend and backend, it's a query language that allows you to see how all of your different pieces of data relate each other in your server. So I look at the two main components in the GraphQL service, which has schema and resolvers. Okay, so schemas allow you to define all of your API per types and fields rather than endpoints, whereas resolvers is the function that determines the value of a property when a valid query is executed on your GraphQL server. How do you perform these GraphQL queries? From graphical tools, all right, which is a built-in tool that comes with graphical or GraphQL package, NPM package, where you can create is your query. So by default, it fetches data from the server. It relies on the HTTP post request to perform that data. Uh, and the beauty of this is because GraphQL solves a common problem in RESTful architectures, such as underfetching, that we lose additionally, so we lose time making unnecessary additional requests for querying multiple collections of data, may increasing the page load time and the overfetching, which the server sends additionally unnecessary data, and we don't need that. But we need to filter out in the browser so we can show relevant data to the user by only having one single entry point where we can query our data and ask for the data that we want. So that's one of the advantages that GraphQL solves. The underfetching and overfetching, it provides new schemas and types and speed up the development process. This is something that was created by Facebook in 2012. So by looking at their specification, you can see how you can create your GraphQL server from scratch. And that's something that on this course we did. I also look at tools where allow us to create our GraphQL clients, such as Relay, that allow you to create a GraphQL client to ask for the data and to perform any operations in a GraphQL server using the React framework. Also, that more high-end products such as Apollo, where they allow you to build front-end and back-end applications, GraphQL applications, and before diving into there, I look at how can I create a GraphQL server from scratch. It's important to do that, especially on Node, using Express middleware and the GraphQL package. By defining it as a type system, where we define all the capability that this server will have, in a more realistic scenarios by designing it as an e-commerce, where most of the time very deep nested objects are very common in e-commerce applications or any application with some technical depth, that looking at, for example, GraphQL tools NPM package that allow us is to modularize these two main components, such as schema, and resolvers. And by modularizes is, well, for our schema, split our files into GraphQL file extension. That's one of them. Help us organize our server by features. And when it comes to structure our server to add more complex logic to fetch our data, we can easily do that as well. So I look at how can we do that for GraphQL, for schema. How can we organize our server with schemas? And that particular approach of breaking your types in multiple files, in using the make executable function to pass all of this array of types array, and using another function like load file sync, which you tell that function where to look for all of these GraphQL files, and then import that into the make executable function or the make executable schema, right? As this type array. And for the resolvers, right, we can pretty much do the same as the schema, but in our case, by defining is the model of the functionality followed by a .resolver.js, where inside of that you export that as a model where you define is the top root operation such as query and mutations, and the query is where you're going to match the name of your query in your schema with the resolvers, and the anatomy of these resolvers is the first argument is four arguments. The first is the parent, the second is the argument that is being used for parameterized query. For example, when you want to filter out data to show that to the user, the context where allows you to share data across different resolvers. For example, authentication data. Okay, checking for authentication. Uh, you want to check if a user login and share that data across different resolvers or all of your resolvers, and the info, which tells you the state of the operation. So then I look at the beauty of this resolver is that they allow us is to make asynchronous code or API code, right? And to keep our code much more flexible and organized as much as possible, uh, we define is the data layer file where we're going to operate. We're going to define all of these functions or all of this access function layer. And in our case, for the sake of the example and for demo purpose, we just use is the built-in memory list of products, for example. So in there, I define is this couple data access function, such as get products by ID, get all products, gets product by range as well, which is another things that I do. Parameterize queries, okay, and I see how can I do that, and also I create my first parameterized query to get product by price, you indicate a range, and get product by ID, okay? And remember, it all starts with your GraphQL, with schemas, right? You define then the capability of your particular type of your GraphQL file, and then you go to the resolver to define that query, and you call that proper function from the data access layer. Great, because Believe it or not, with GraphQL you can also is create crew operations, operations that are that are common in backend applications. Create, read, update, and delete. In create, so we already saw how to read data, okay? And one of the things that GraphQL focus on doing very well is on making queries because APIs uh, gathering and reading data is probably the most common thing you ever do. So when it comes to check the state of the application, like create, update, or delete, we rely on mutations. I also see how can I implement mutations. Okay, again by looking at the schema, define this type root level operation in GraphQL, and set the name of the mutation. In our case, we define these two mutations, something that I can show you here. Blah, 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 blah. In our product here, our mutations, like this, okay? Or mutations, like add a new product and got a product review, and by creating this huge pipeline here. What I mean is by setting is the mutation, the argument it received, and the return value. This is a fairly common pattern when in APIs that indicate that this data was saved, right? When you create that. And the other is add new product review. So okay, cool. Because with this mutation and add new product and add new product review, right? Uh, then I look at the resolvers, okay? Which resolvers again is another component of any GraphQL server. You have schemas and resolvers, and the type of operation you can do to a GraphQL server are query, mutation, and subscription. Something that I'm going to explain later. So it all starts here describing this our mutation on our GraphQL files. Then look up for the proper resolvers, and inside of this is where we set the mutation object, which is a map right below the query. It takes the name of the mutation and some arguments. So to make our resolver as small and thin as possible, we just only call that access function, that access data layer function that will take care of that logic to fetch the data. In our case is to add a new product, and we're gonna pass it the proper argument it needs, right? So we want to make these resolvers independent to whichever model we want to use, any database or any other implementation detail. So once I look at the data layer file here, this is what I define is the logic for this mutation, and taking it as the newest scenario. Okay, taking here is the best possible scenario. All right, and they export that function to that. I also saw on how can I implement another mutation and understand how mutations work and how to make multiple mutations. So again, looking at the product GraphQL file, I add a new product review with the particular argument and the return type. which is review, and on the resolvers, we again define is the resolver name and the mutation name and the resolver function. We call that function from the access data layer. We pass the argument it needs, and uh, we'll find here is the logic that will take care of this. So to add a new product. And on our front end, or particularly on our graphical tool, okay, because to make multiple mutations, the way to do that is by defining an alias, since think here what will be the return object you will get if you don't define that. Here, by adding a new prompt. Let me round this to get a clear idea of what I'm talking here. And then use, I have to indicate is the version of Node I would like to use. Then tell npm start this server. Okay, and the GraphQL server. The local host here is on GraphQL here, and here we go. Right. So imagine what will be is the returning object from this mutation, right? So we're gonna get the rating and the rating. So how do we know? How do we indicate how? How? Yeah. How can we know which rating belongs to which one, right? The answer lies on alias here. So here we're getting is first we define the mutation keyword. Remember, because GraphQL or because in APIs, gathering and reading data are probably the most common thing you will do. So by default, if you don't define anything here, it retrieves data. Okay, we fetch data. That's one of the things that they don't recognize on query. All right, but on mutation, when you want to modify the state of your application, you need to set that keyword, add a new product, show review and jacket review as a part of making multiple mutations. So mutations here are performed in series. Okay, so if I take a closer aspect here of the network tab, network, 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 network. This is on the Spanish, and when I perform this, look at this. We just only make one single request, okay, to perform mutations here. Okay, this might be is different individual requests in a RESTful architecture. Okay, whereas the uh, response is this, and this is our request here. So it passes that as a string. We use it as a graphical tool for that. If you can read more about this here, that's right. And you will see intelligent type of heads, blah, 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 blah. But they send is this data for that. They say a mutation with a new product, and that data it sent that as an HTTP post request. Okay, which contain the whole data, the whole object here. So GraphQL server takes that, it interpret or it read that, perform the mutations in the server by per serial one by one, and then once it resolves or once all of the resolvers function has been executed, it will wrap up and send it back to the client. So again, is delegating is all of this load to the server. Is delegating all of this load to the server. Okay, okay, makes sense. Okay, that's actually pretty good. Pretty awesome to see that. So yeah, we implement our mutation, how to do that, and how to make multiple mutations. Cool, cool. That's actually pretty interesting stuff. Now, here comes the interesting things here with GraphQL with Apollo. So Apollo is the industry standard of GraphQL implementation, providing the data graph layer that connects mother apps to the cloud. And there's some like a lot of jargon here, a lot of stuff here going on, you know. And there's a lot of jargon and things and stuff going on here. And is this. So GraphQL with Apollo. So Apollo is the industry standard of GraphQL implementations, providing. So that's right. So Apollo is the industry standard of implementing GraphQL servers, uh, providing important thing to know, providing the data access layer that connects mother apps to the cloud. Providing the data access layer, providing the data graph layer. Okay, providing the data graph layer that connect mother apps to the cloud. Okay, so they providing is that layer of infrastructure, GraphQL. So GraphQL is providing that layer of infrastructure. So what you have is your front end, you have your backend, you have your front end, the network, the backend, and inside of the backend, you have this data graph layer that allows you to connect to different sources. Okay, that connect mother apps to the cloud. There are some advanced tools if you really want to commit to their platform that help you build GraphQL project as part of a much larger team, like Apollo Federation, Apollo Studio, and Rubber CLI. So Apollo Federation implements a single data graph across multiple servers. Okay, but again, GraphQL provides you is the data graph layer that connects more apps to the cloud. Okay. And there's some more advanced tools if you really want to commit to their platform that help you build GraphQL project as part of a much larger team. Yeah, there are some advanced tools if you really want to commit to their platform that help you to build GraphQL project as part of a much larger team. Okay, and then you have Apollo Client. It's a set of front-end library that helps makes GraphQL query and save GraphQL data on your front end. Okay? So there's some more advanced tools you really want to commit to the platform that help you to build GraphQL project as part of a much larger team, or with greater or with large team. Okay, okay. So that's what GraphQL according to the website. GraphQL, no, it is Apollo GraphQL. Mother apps are built on the supergraph, which unify all clouds and servers into a single connected map that developers can query with GraphQL. Leading companies from startup to Fortune 500 use the supergraph to power their flagship apps. It's a lot of. This is one of the things that I love from writers. It's one of the things that I love from writers or copywriters. Uh, the way how they use the language to describe this omniscient, uh, very abstract thing, right? So build better apps faster. Ship tomorrow's roadmap today. Ship tomorrow's roadmap today by removing the first bottleneck in future development process. Reduce costs by eliminating millions of lines of boilerplate code. Onboarding app developers to create the future. Get your GraphQL API on Supergraph. I think they will give this their sign up to their servers. Exactly. Get started with Apollo Graph OS. No, man, it's like, ooh. And again, this is one of the things that I see valid from that. Because now data will come from different sources. For example, RESTful architectures, that different database, or any different data source. That's what I see is this. So that GraphQL is a so that Apollo is an industry standard of GraphQL uh, implementation, providing the data graph layer. They tell you what they use, and providing the data graph layer that connect mother apps to the cloud. They provide you this data graph layer. Great. Okay. Things are starting to make more sense because you understand the fundamental here. Things are starting to make a lot of sense because you know the fundamental. It's like, okay, alright. Okay. So Apollo client is a set of front-end library that helps makes GraphQL query and save GraphQL data on your frontend using Apollo is much more convenient than making HTTP post requests to your GraphQL endpoint directly. So again, Apollo is a set of frontend libraries that helps make GraphQL queries and save data on your frontend. So, set of frontend libraries that allow you to make GraphQL queries and save data. Using Apollo is much more convenient than making HTTP post requests to your GraphQL endpoint. Of course, uh, it lets you query your GraphQL server much like you will in a graphical. Exactly. It lets you query your GraphQL server much like you would in graphical. And it comes with added benefits. Catching your queries, handling load states, and errors and keeping your data synced with the server. And then you have Apollo server. It allows you to create a GraphQL server in Node, very much like our GraphQL package. Even better, it helps you run and deploy your server code to serverless environment like Lambda. It includes functionality to help you implement subscription, which is another root level operation, where subscriptions allow you to push data from the server to subscribe clients, much like push notifications in your phone. So I think they make it much more easy to do that. By abstracting is the way how you do that. By extracting is the observer design pattern. So Apollo server wraps all of this functionality in your GraphQL server and exposes it individually in a set of npm package. I'm gonna make a quick pause here. Okay. Uh, okay. So GraphQL is this industry standard. Okay, so GraphQL is this industry standard of GraphQL implementations providing the data graph layer, providing the data graph layer to connect mother apps to the cloud. So they are providing is that layer, a data graph layer. The data graph layer. So they're providing is that. And there's some more advanced tools if you really want to commit to the platform that help building a whole project or help you to build a GraphQL project as part of a much larger team. So I understand what Apollo is, GraphQL with Apollo, right? Since GraphQL allows you to see how all of these different pieces of data relate in your server, it's one of the beauty of this, okay? By solving problems such as overfetching and underfetching, meaning reduce waiting load time and decrease the page load time, so more likely to generate user retention and user conversion. Okay, so Apollo is this industry. So Apollo is this industry standard of GraphQL implementations providing the data graph layer that connect mother apps to the cloud. Okay, makes sense. So with Apollo client, okay, we have a set of npm. Yeah, we have a set of libraries. So we have or Apollo client is a set of Apollo client is a set of front-end library that makes GraphQL queries and save your data on your front-end much more convenient than making a single HTTP post request to your GraphQL endpoint. So it lets you query your server much like exactly it lets you query your server much like you will do it lets you query your server much like exactly it lets you query your server much like you will in graphical, okay, and it comes with added benefits like catching, handling loading states of network operations, handling loading states and errors, and keeping your data synced with the server. Okay, this is the things that the Apollo client allow you to do, right? A set of front-end uh, tools or libraries, a set of front-end libraries that help makes GraphQL query and save your data much more convenient rather than making an HTTP post request to your GraphQL server, and it comes with some benefits like we can query our GraphQL server much like we will or much like you will in a graphical uh, catching provide catching, handling loading state and errors. Yeah, handling loading states and error. So you provide catching, handling load state errors, uh, querying your data much like you would in graphical, and keep your data in sync with the server. Okay. And then I look at the Apollo server. Okay. So the Apollo server, it allows you to create a GraphQL server. And you know what? This is a common pattern. When you have the client and the server, you know? Most of the time, a client is in a set of front-end libraries that allow you to do a particular thing. Okay, and it can come with a couple benefits that are similar to this, which is catching, handling network states, or handling loading and error states, and keep your data in sync. So this is basically, I will argue that most of the client library will do, right? So okay, good. And then you have is the Apollo server, which allows you to create GraphQL server in Node environment. Okay, very much like your like in Node, very much like our GraphQL package. So with Apollo server, it allows you to create GraphQL servers in Node, very much like our GraphQL package. Okay, so with Apollo server, allow you to create GraphQL server in Node, very much like graphical or the GraphQL package. Even better, it helps you to run and deploy your server code to serverless environment like Lambda. Kind of the great thing of this, because on Apollo it helps you to run and deploy your code to serverless environment like Lambda. It includes functionalities to help implement subscription in your server. Okay, it includes functionality to help implement subscription in your server. Another root level operation where subscriptions allow you to push data from the server to subscribe client. That's the another thing that's what subscriptions allow you to do. Push data from the server to subscribe a client, much like push notification in your phone. An Apollo server wraps up all of this functionality in your GraphQL server and exposes it individually in a set of npm packages. Okay, and the Apollo server, exactly. So the Apollo server wraps all of this functionality, like allow you to create a server in Node, very much like in very much like uh, very much like with our GraphQL package, allow you to create GraphQL server, run and deploy your server code to a serverless environment like Lambda, okay, and it includes functionality to help you implement subscription. According to this, so they summarize all of the things. Perhaps it allows you to do more things. Uh, but it includes functionality to help you implement subscription in your server, which is another level operation where subscriptions allow you to push data from the server to the subscribe client, much like much like push notification in your phone. So Apollo server wraps all of this functionality to allow you to create GraphQL server in Node to run and deploy your server code in a serverless environment. The serverless might be deceiving because after all, the user is a server to run that. But the serverless here is that you don't have to handle a server for that. But that's the beauty of this, right? I like it. So with serverless, you don't have to worry about the hassle of how to handle a server. All of that has been taken care of when it comes like scaling your data or adding more resources to your server, scaling your database, create more Node.js instances for redundancy to improve performance. So all of them are taken care for you. It's okay. That's serverless. Okay, they allow you to run and deploy serverless. Uh, it allows you. So Apollo allows you to run and serve or deploy server-side code in a serverless environment like Lambda, and also helps you to implement subscription, where it allows you to send data or push data from server to subscribe client, much like pushing the notification. And all of this functionality uh, are wrapped in a set of individual npm package. Okay, okay, okay. To me, makes sense. Okay, to me, this shit started to make sense. Okay. To me, this shit started to make sense. Okay. So with that, uh, so that'll be all for this video. So take care. Bye bye.